Today we're talking about section 1-5, which is measuring segments. So the first thing that I want to talk about is a new vocabulary word. And so two segments that are the same length are called congruent segments. And so congruent may be a new word for you, it may not be, but either way it is a vocab word, so you might want to underline that. So congruent segments are two segments that are the exact same length, which makes sense because the definition of congruent figures is that they're the same size, same shape. So this would make sense that two segments that are the same length would be congruent because we already know they're the same shape, they're both segments, and that they're the same size if they're the same length. One other thing that I want to point out before we continue is that the symbol for congruent is an equal sign with a little squiggly on top. So make sure that you know that because I will probably just do that symbol from now on rather than writing out the word congruent. That's something that you need to be familiar with. So an example of two congruent segments might be if I have this segment, and we'll call this one AB and this one CD. If I told you that they were both 7 centimeters, we would know that they're congruent segments, so we could write that as AB is congruent to CD. And that's showing that those two segments are the same size, same shape. So we're going to learn a new postulate today, and that's the segment addition postulate. And the segment addition postulate says that if 3 points, A, B, and C, are collinear, and B is between A and C, then AB plus BC equals AC. So this might make more sense if we draw it out. So let's draw a little segment here, and we're going to put 3 points. We're going to put point A, point B, and point C over here. So all this is saying is this plus this equals the whole thing, right? Kind of common sense. So an example might be if this is 9 and this is 15, what would AC be? Well, we know that AB plus BC equals AC. So 9 plus 15 equals AC. So AC must equal 24. So it really doesn't get any more difficult than that unless we decide to add some algebra into the equation. So if we draw another segment, and we'll say that this one has points D, S, and T. Okay, so if this is 2x minus 8 and this is 3x minus 12, but I give you the information that dt is equal to 60, and I ask you to find x, ds, and st. So we know that ds plus st equals dt. So now we can just plug in what we know exactly like we did when we were working with all numbers. So we have 2x minus 8 plus 3x minus 12 equals 60. And now it's just a simple algebraic problem. So we can combine our like variables. So we have 5x minus 20 equals 60. We add 20 to both sides. So 5x equals 80. Divide everything by 5. So x must be 16. Okay? And whenever you have one of these problems, I'd like for you to make a little answer box over in the corner so that you can make sure that you keep all of your answers nice and clear. So we have x and then we have ds, and then we have st. So we already have one of our three answers. We have x is 16. Okay, so then what we do is we take that value of x and we plug it into our information. So ds is equal to 2x minus 8. So we just plug in 16 for x. So 2 times 16 minus 8. So we have 32 minus 8. So ds is equal to 24. And then finally we have st, which is equal to 3x minus 12. So 3 times 16 minus 12. So 48 minus 12. So st is 36. And you can check yourself by making sure that that first statement that we used is still true. So ds plus st equals dt. So we have 24 plus 36 equals 60. So 60 equals 60, and that is true, so you are correct. And this is a really good way of checking your answer to make sure that you did it correctly. So if you have any questions, please feel free to email me.